I think that when people hear physical AI these days, it's still a little bit abstract. We can all appreciate what generative AI is doing in software, and we can certainly all kind of appreciate the value of atoms-based physical technology. But the marriage between these two things is still relatively new, and both of you are invested in and working on autonomous cars. Why are autonomous vehicles, trucks, cars, it's kind of the platonic ideal or the ideal form of physical AI? And I'll start with you, Raquel.
Yeah, I think when you look at what is the application domain where this idea of AI doing tasks in the physical world is going to really impact and influence and change the world. Self-driving is where we believe that the big revolution is going to happen first, and there's been a big shift, I will say, in the industry in terms of how this was approached 20 years ago, where Sven participated and led one of the teams, Stanford team, for the DARPA challenge, and where it is today, and the impact that this next generation of AI really is bringing to finally building a scalable solution. And perhaps Sven, you want to drive us through your experience in the last 20 years.
Yeah, the way I think about self-driving, I have fond memories of, and so I have a certain love for that in general. But just economically, it's an incredibly large market, so that's the bit that makes it very attractive. The other thing, as opposed to a lot of other robotics, being right really matters in self-driving. You can't be 80% right when you're self-driving, in particular if you're driving trucks. Those are big things. And so to me, it is a little bit the pinnacle of engineering robots, because they really need to work. They can work in a very, very large market. They can really reshape logistics supply chains if you do it properly. So it's a very large opportunity, but you also have to be very good at getting it done.
Right. And it's something that I think the average person can sort of understand the importance of. We all get into cars and trucks fairly regularly versus maybe industrial robotics, where it is, once again, still a little bit abstract in terms of how it affects our lives. I thought it might be useful to talk a little bit about what Waabi actually builds, because it is fascinating. As I understand it, and please correct me if I'm wrong or elaborate on it, is that this generative AI, the way that it's going to work in self-driving, is that it makes a truck it makes the system adaptable in real time, gives it kind of human reasoning capabilities as the truck is on the road. So if there are these unforeseen scenarios or geographies that it can sort of adjust in real time. Talk about this.
Yeah. And when I started the company 4 years ago, I saw a tremendous opportunity to bring next generation of AI technology. This is before the ChatGPT moment, right? Thinking that this will really revolutionize the way that we approach self-driving, so that we have a much more capital-efficient approach, faster path to market, and at the same time save many, many lives. And it was rooted in two differentiated technologies, I will say, or two big pieces. One was, the traditional way of doing self-driving was, this massive, I call it a spaghetti stack that was hand-engineered by humans, where it was very brittle, where you needed to drive, millions of miles in the real world to try to see what is the next set of corner cases that the system cannot handle. So this was something that, I didn't believe that it was going to provide us the opportunity to really build something that can truly scale and solve, what our customers really want to have. So with our approach, it's an end-to-end system, meaning a single AI system can do all the tasks for driving, but it's able to interpret what is sensing, and is able to use these interpretations to reason about what are all the things that it can do and what are the consequences of its actions. And this is very important, because then it can really understand the risk of every possible maneuver that it can do, and really always choose the right action. And this gives us the ability to generalize with very little data to things it has never seen before, which is a must-have when you are, driving with, a robot driving an 18-wheeler with 80,000 pounds, behind you, right? And the consequences obviously are tremendous. And the second kind of thesis in terms of technology for Waabi was that, we will never drive enough to see everything that can happen in the world, right? No matter how big your fleet is. So the idea was, well, if you can build, say, the matrix for self-driving, you can build a simulator where it's the same as the real world, then with no consequences, you can expose the system to accidents, safety-critical situations, all corner cases, and things that will take you, many lifetimes to ever observe. And, and it was, an incredible, I will say, this was before any neural simulator, anything was built. And it turned out to be like really the right approach because, as you know, in the area of AI, data is more than half the equation. So with that simulator, we can train the system, we can test it, and provide, the evidence that indeed is safer than humans. So it's been, it was very, I would say, different than anything else when I started the company. And 4 years in, you see now that has becoming kind of like the trend. Yeah. But it was very contrarian, I guess, at the time.
Sven, what led you to invest in Waabi? And you're also on the board.
Yeah, so I've been following the history of self-driving, and it went through a couple of changes. So in 2005, there was a grand challenge. Right after the grand challenge, everybody got super excited about self-driving. Yes. Lots of startups got started. Some tech primes got into self-driving.
Right. And just so folks know, you were on the team at Stanford. You led the engineering team at Stanford that actually won the Stanley self-driving.
Yeah, I was one of the people contributing to the team.
Very modest of you.
And
always.
So people got very, very excited. And it is actually, the dirty secret is, it's actually not that hard to make a self-driving car or truck that kind of works. It really doesn't take that long to build one that can drive up and down a highway or something like that, somewhat unreliably. And so people were building those and then trying to nail down the corner cases. And you need ever larger fleets that costs ever more money. And you're not quite sure if you've really nailed all of them down. Every corner case that you then need to solve requires more software development. So you go slower and slower the larger your code base was. So now it's 20 years later. It's 2025 now. And so when Raquel approached me, I was kind of unsatisfied with the state of self-driving. And Raquel basically like, yeah, I have this idea of the simulator. And the simulator would genuinely help us clobber down these corner cases. The same an end-to-end train system. And to me, that was hugely appealing. I always wished I had a thing like that. Raquel can magically instantiate a 3-lane highway, make it a 2-lane highway, make it rush hour traffic, make it not rush hour traffic, have aggressive drivers, docile drivers, any sort of variant that you want. And I always wished I had something like that to test the robots in, and it was hugely attractive. And we spent then the first time in the company not really building trucks, just building the simulator. And it became the tricky thing with the simulator, you want the gap between reality and simulation to be as small as possible. And so that was a big chunk of work.
And Raquel, you used to work at Uber. You were running R&D of the autonomous trucking group there for nearly 4 years. And you're working with Uber now, right? You've partnered with Uber as part of this deployment. So explain how your software is now actually working in Uber trucks or being tested in Uber trucks.
Yeah. So, before Waabi, I was chief scientist and head of R&D for Uber. I work both in robot taxis as well as self-driving trucks. That's one of the, where I really also learn about how exciting the unit economics are for tracking and whatnot. But the way that we work with Uber, obviously they are a big investor of Waabi. But at the same time, we have a really exciting go-to-market partnership with Uber Freight. Where think of Uber Freight sitting in the middle of supply and demand. You have the carriers that own the trucks. You have the shippers that have the loads that you want to go from point A to point B. And we provide the virtual driver, and they do kind of the matching in terms of getting our trucks driving 24/7. Working with the top Fortune 500 companies. So with this very exciting partnership, what you will see is a deep technical integration, where it's seamless for both shippers and carriers to get access to Waabi Driver, to our technology. And the other thing that you will see is that we have billions of miles of committed shipments to be within the Uber Freight network. And today they have 20 billion of freight under management, which is it's a massive I will say, they have access to, the majority of the market. So it's a very exciting go-to-market, for us to work closely with Uber. And, definitely we have, a great relationship that started with, during the Uber days with both Dara, CEO of Uber, as well as Leo Ron, CEO of Uber Freight. And, we continue to go through this relationship, but is really for us, accessing massive customer base without building big sales organizations, right?
There's this sense, doing self-driving trucks is hard. Like, it sounds like doing cars is hard, but trucks is harder for various reasons. And I'm curious, how many people here have actually been in a self-driving car? Anyone? I'm seeing some scattered. Okay, yeah. I live in San Francisco where we have Waymo, and I love Waymo. And actually, when I first moved to Silicon Valley many years ago, Google was testing its cars through Mountain View at the time. And I remember the first time I saw one, I was operating my car, and I stopped and took my phone and started filming the self-driving car. And I thought, this is the only data point that you need to prove that self-driving is safer, because I was veering all over the road as I was using my phone. So we have the sense, and there's plenty of data that support that self-driving could be safer. And yet when it comes to trucks, when it comes to 10,000 pounds or more, when it comes to speeding down the highway, carrying freight, it's kind of uniquely terrifying, right? Can you talk a little bit about the challenges that come with making trucks work autonomously versus cars?
Yeah, I would say that, robot taxis and self-driving trucks have different challenges, right? And the robot taxi side, urban core, where humans do all sorts of crazy things, is the major challenge. In terms of trucks, from a technology perspective, you need to see much farther. And the reason why is that trucks, even driven by humans or robots, the maneuvers that you can do, are much smoother, and it takes longer. Just by the physics of you are carrying, as I say, 80,000 pounds, you cannot just, swerve. You will just flip the truck. So that's one of the, I would say, difficulties. Also, controlling variable loads and whatnot makes it, more challenging from the dynamics perspective. But at the same time, is also a massive opportunity. There is, if you look at the, the industry today for truck drivers. Not everybody is a N million miler. There is a lot of novice drivers where they have a lot of responsibility into driving trucks that can have tremendous consequences. And self-driving trucks, there is no doubt that they will be so much safer than any human, right? So from that perspective, is a great opportunity so that we minimize the probability of any bad event happen, right? And we save many lives. But they are absolutely superhuman, no doubt about it.
Sven, did you have anything to add to that in terms of the challenges of building autonomous systems for trucks?
Yeah, I agree with Raquel. It's just slightly different challenges. There's some things that are, I think, considerably harder for trucks. The vehicle dynamics are more challenging, sensor range is more challenging, all of these things. There's some things that are a little bit easier. So for example, driving in Manhattan with Manhattan-type traffic is not typically a thing that an 18-wheeler does. They mostly drive highway miles. Highways are a little bit easier to reason about as a place like Manhattan. So there's good things and bad things. I think the consequences for trucks are just high, so you need to be really good at what you're doing. I think the economic opportunity is actually better in trucks.
I was going to ask you about the unit economics.
So there's a reward for this too, for this challenge. Well, so in self-driving cars, you need to amortize a sensor suite that is a non-trivial sensor suite. So you have a car, and then you have a bunch of sensors. If you look at a Waymo car, for example, you will see a bunch of LiDARs on the car, one on the top, 4 in each corner. You need to amortize this over the set of rides that you do. On a truck basis, it's just a much different equation, because it's a similar sensor suite that is really there, maybe a little bit longer range and so on, but first order of magnitude, kind of the same thing. And you get to amortize it over the cost of a truck, basically operating constantly. So it's a much easier equation. The second thing is, in self-driving cars, customer acquisition is a real cost. You need to convince people to use your ride service as opposed to the next person's ride service. Trucking doesn't work like that. You can have large arrangements with large shippers, or in our case, Uber Freight. So you have way more customer concentration. You can make a small number of deals without having to spend an enormous amount on customer acquisition in order to end up with a very profitable business.
Fascinating. What about the regulatory challenges? You're having to navigate a lot of those as well. Right now, I believe that self-driving trucks can test in a few states around the US. California is now also considering allowing that. Texas tends to be a place where a lot of these trucks are being tested. It's complicated. Talk about that.
Yeah, so actually the regulatory framework in the US is actually really favorable for self-driving trucks, and in the majority of the states we can deploy driverless trucks. I was just in DC with Secretary Duffy, and it was great to see that the willingness to create a federal framework that will really enable this industry to expand to the entire United States, right? So that you don't need to go state by state, sort of working with regulators in order for to have a path to deployment. But it used to be in the past maybe one of the potential challenges, but right now what we see is a very, very open regulatory framework.
Sven, how much are you factoring in the regulatory environment when you consider an investment like this?
So as I don't get to control the regulatory environment,
I
only get to have an opinion about it. So it has gotten better as a function of time. Now, it is still a risk, but at the end of the day, in the business that I am in, my job is to bet on extraordinary people and large markets. And then the regulatory framework, as long as it is not like punishingly prohibitive, is like a second consideration, because it's just too much value that gets generated here. So we, as a society, will find a way to allow this in kind of a safe sort of manner.
What do you envision happens to jobs for truckers, for full-time truckers, when this becomes more widespread?
Yeah, so one of the things that people need to realize is that it's not that suddenly you flip a switch and then everything is autonomous. This is the physical world, so penetration, scaling, adoption is going to take time. So we believe that any truck driver today that wants to retire as a truck driver will be able to do so. There was a recent, very interesting study by the U.S. Department of Transportation that shows that self-driving will create more jobs that it's going to displace, and those jobs are much better. What people don't realize is that being a long-haul trucker is really, really difficult. You go, weeks at a time on the road, and oftentimes, for many, many days, you don't have access to even, toilets, showers, etc. If you're a woman truck driver, there is huge safety issues, by being sleeping on your truck. So what we see with this technology is really enhancing the kind of jobs that we can do, and it's going to create things like, remote assist, terminals, enhanced inspection, jobs, etc., that will be more exciting for humans to do, right? So we see automation as an enhancer, not as, really removing the human from the equation.
I think we have to end it there, but thank you so much for your insights, Sven, Raquel.
Thanks for having me.
Thank you.
Thanks,
everyone.